Scientists are working on exciting new projects involving space travel. NASA is sending a helicopter to Mars. The aircraft will travel to the Red Planet by 2020. Trinity Chavez explains.
The U.S. will be the first nation in history to fly the first heavier-than-air aircraft on another world. That's right, NASA is sending a small autonomous helicopter to the Red Planet. The rotorcraft will travel with the agency's Mars rover mission, which is expected to launch in July 2020. The small Mars copter will make a series of test flights to the Red Planet, which NASA says will enable more ambitious missions in the future. The full 30-day flight test campaign will include up to 5 flights of incrementally further flight distances, up to a few hundred meters each time, and longer durations as long as 90 seconds over a period. NASA Administrator Jim Bridenstine said in a statement, "The idea of a helicopter flying the skies of another planet is thrilling. The Mars helicopter holds much promise for our future science, discovery, and exploration missions to Mars." NASA's Jet Propulsion Laboratory began developing the 4-pound helicopter back in 2013. Only about the size of a softball, NASA officials said that the size of the copter was of utmost importance. Mimi Ong, Mars helicopter project manager at JPL, said in a statement, "To make it fly at that low atmospheric density, we had to scrutinize everything, make it as light as possible while being as strong and as powerful as it can possibly be." The 6-wheeled rover will be equipped with several cameras, a microphone, and a drill to collect samples. Its goal? To hunt for signs of habitable environments as well as sites that may have once hosted microbial life. The Mars rover mission is scheduled to launch in July 2020 from Cape Canaveral Air Force Base in Florida. It'll reach Mars by February 2021, and according to NASA, if the helicopter does fail, it will not affect the rest of the Mars rover's mission. Reporting in New York, Trinity Chavez, RT.
So as you can see, we're using the vacuum chamber once again, and I actually have a little feather right there, as you can see, suspended in front of a 12-volt electric fan. See, I got the batteries, a pressure gauge, and everything in there. To turn it on, I have a little tilt switch, says magnetically controlled. You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So, I want to take this down to Martian conditions. You might have noticed the Martian reference over there. The first thing I'm going to do is add a little bit of dry ice to the chamber, just so that the atmosphere gets replaced with CO2. Many of you guys were complaining about that last time. So now I should have a CO2 atmosphere, or at least it'll create one. And now we're going to suck out all of the air, or at least most of it, down to the point or about between 4 to 6 millimeters of mercury, which is, of course, the pressure on the surface of Mars. So let's plug in the vacuum pump. There we go. Give this a little while to suck down. These pieces of CO2 look really interesting in the vacuum. The gas produced causes them to levitate and float all over the place. But if you can see the gauge over there, you can see that the air pressure is just about to the point where it would be considered the surface of Mars. Let's see what happens. Okay, fans on. And the feather's not moving. In fact, let's zoom in on that. Not even flinching. Just turn the fan off. Okay, and let's turn it back on. So there you go. Now, extrapolating from that, you can imagine that even a 200-mile-an-hour wind on Mars isn't going to do much. So to finish up this experiment, I'm going to turn this fan back on, just like this. And now I'm going to let the air back in, and let's see what happens as we come back to Earth. Yeah, almost immediately you can see the feathers start shaking around more and more violently. Okay, so the air stopped coming into the chamber, so now everything's due to the fan. What I think is interesting is the fan actually sounds different. It doesn't vibrate quite as much. So there you go. The air density has a big impact on what wind velocity actually does.